And so in this example, we are factoring a quartic. And once again, I want you to compare the box method to the synthetic division and the polynomial long division. Now, what's happened is we've picked out the fact that f at 1 is 0, and of course that means that f minus 1 is a factor. And so we're ready to go on our merry way and try and factor this polynomial. Okay, so this is the box. Ordinarily, what would go down here is what I multiply x minus 1 by to get this polynomial. I can actually sort of sleuth this thing out. So I know that I need an x to the fourth term, so the polynomial in the expansion has an x to the fourth. I know that this has got to be an x cubed here in order to multiply by x to get x to the fourth. And if that's an x cubed, then this is a minus x cubed here, because x cubed times negative 1 is minus x cubed. I have minus 3x cubed in my quartic, and so that means that this is minus 2x cubed, because those add up to negative 3x cubed. If this is minus 2x cubed, what times x gives me minus 2x cubed? Well, that's minus 2x squared, which when I multiply by negative 1 gives me plus 2x squared. I have negative 13x squared, and so I actually have to subtract 15x squared to get that negative 13x squared from these two terms, which means that this is a negative 15x, which means that this is plus 15x. Now I have 3x's here, and I have 15x's here, and so that means I'm going to have to subtract 12x's to make that work. And so that makes this a minus 12, because minus 12 times x is minus 12x, which makes this a plus 12. And so I automatically know I've probably done it right, because it starts with x to the fourth and it ends in 12. And if I add these together, I get the appropriate coefficients for this polynomial. And so the factored form is going to be x minus 1 times x cubed minus 2x squared minus 15x minus 12. Now, from what I can tell, if this box method works better for you, and it works better for me for sure, you can use this instead of polynomial long division or synthetic division.